is I'm going to do a proof that a to the n, no. Let's do a to the 2. I think this might have been on the old final. B to the n, c to the n is not regular. Okay? Alright, so let's do a proof of this. So I guess my statement, and I'm trying to follow my outline, but you guys have my outline in front of you possibly, and I would strongly recommend bringing it to the exam. But, right, you got 5 pieces of paper. There's tons of stuff you can bring. I think 5 pieces of paper was meant to be super more than you could possibly need. But if I'd said 10, you would have tried to find stuff to put on 10, so I figured 5 was a good number. Okay, so a to the 2b, all right? So here's my proof, right? I suppose I've already messed it up from my outline, so prove that this, okay? So my proof statement. No, I don't start with the statement in my proof outline for
Start with the statement.
and then I say, all right, so I do statement a squared b to the n c to the n, and I suppose really this should be something like that. It's not regular, right? So that's my statement. And let's assume that my statement is false, right? Am I following my outline so far? Assume my statement is false. That is a to the 2, b to the n, c to the n is regular. Yes? Are you looking at my outline and am I following it?
It's close enough.
Close enough, all right. So I don't have it in front of me for points, using my outlines. Take home you absolutely have to do, no, you don't absolutely have to do one of these if you're on your own, but if you're doing a proof for the take home, use my outline, right? There'll be some points in there. Okay, so I'm going to assume that's regular, right? Which means that the pumping lemma for regular languages applies, right? Which means I can pick any old string I want, right? And I can pump it, right? So I'm going to pick a string, and typically when you do these proofs, your first choice is to try and use m, where you say m is the number from the pumping lemma, right? So I'm going to pick the string s equals a squared b to the m c to the m, where m is the number from the pumping lemma. Okay? So, if m was 5, then the string I picked was AA followed by 5 B's followed by 5 C's, right? And if m is 27, then I have 2 A's, 27 B's, and 27 C's, and so on. You guys with me? Yeah? All right. And from the pumping lemma, I know that, right, I can split S into X, Y, and Z such that S equals the concatenation of X, Y, and Z, right? And the length of X, Y is less than or equal to M, right? And I don't remember how I say it in the thing. The length of y is greater than 0, right? I might say it like that. Another way to say that is y does not equal lambda, right? But that's the magic of the pumping lemma. The pumping lemma tells me this. Now, my goal in this proof is to, try and come up with some sort of contradiction, right? So what I'm going to do now is I'm going to play with my string, and I'm going to say, oh dear, my string can't have all these things true, right? And have these things true and be able to be pumped, right? So let's take a look at, I know I can split it into that and that. Let's make this my language. L equals that thing is not regular. And x, y to the n, z, such that n is in the natural numbers, that all of these strings are, I guess that's a subset of L, right? That this set of any strings that I pump is in my language, right? Any string of this form is in my language, or all of the strings of this form are a subset of my language. You guys with me? Right? So let's keep going. So now we have to think about, well, at this point, if we think about what is x, what is y, and what is z, we usually win. But you guys asked me specifically, could I come up with an example where there may be a couple of chances before I have a contradiction, right? So let's take a look at what x could be, what y could be, and what z could be, right? We know from the pumping lemma that the xy comes at the start, and there can be at most m characters in it, right? So if I look at my string, the xy part, right? Let's talk about the xy part. The xy part well, I guess the xy part could have just some a's, right? It's possible that the xy part is just some a's, so there's two a's in the beginning. It could be that, right? It could have some a's and b's, right? But at most m characters, right? I don't usually put this piece in the proof. I usually go straight to the x, and the y. But help me out for a minute. Does everybody see how the xy part could be just a's, right? Maybe one a or two a's, or the x, it could be some a's and b's, but it has to be the end of it, so it's got to have all those a's in there somewhere, right? So now let's talk about the y part, okay? So what could the y look like? Case 1. So x can be empty, right? But y cannot. Y has to have something. And it has to happen in the first m characters. So I think there's three possibilities here. Y could be just have some a's in it. Y could be some a's and some b's. Or y could be just some b's and the x could take care of the a's. You guys with me? Now, if one of those ways works in my proof, and I don't have a contradiction even in just one of those ways, it's fine, right? No contradiction. Like if I say, suppose I want to I want to prove that I am holding chalk. Or I'm holding a writing instrument, let's see, okay? And the only writing instruments that I could possibly be holding are a pen, a pencil, a whiteboard marker, or chalk, right? And if I say, well, somehow I prove it's not a pen, that doesn't tell me I'm not holding a writing implement, right? It just tells me it's not a pen. And if I say, okay, it's not a pen or a pencil or a whiteboard marker, but I can't prove it's not chalk, there's no contradiction. It could be chalk. You guys with me? I could be holding a writing implement. If I can't get rid of every single possibility, then, right, if I don't have a contradiction for every possibility, then my statement could be true, right? So what we need to do is we say there's three cases for y. Y is just A's, right? I'm going to kind of draw a line here. Case 2, y is A's and B's, right? And case 3 is y is just B's. Okay. So let's think about this. If y is just A's, right, then what's the smallest y could be? Has to have one thing in it, right? And it's just A's, so what's the smallest it could be? A. How many A's are there? 2. What's the biggest it could be? AA, right? So if y is just A's, then y is a to the n. Oh, let's not use n because we already used n somewhere else. Y must take the form a to the p, where p is greater than or equal to 1 and less than or equal to 2, right? Yeah? And so x is going to be whatever a's came before that, right? So how many a's are there in x? If y is 1a, how many a's is x? 1. If y is 2 a's, how many a's is x? 0, right? So x is going to be a to the 2 minus p, right? For whatever that p is, right? And z is going to be, oh, is that true? Wait a minute. Let's suppose y, no, I'm wrong. Suppose y is the first a, right? X could be nothing, or it could be just 1a, right? So x is going to be a to the q, where q is between 0 and, I guess I'll say 2 minus p. Does that work? I think so. Tell me if it doesn't work. But like if p is 1, then x could be between 0 and 1, right? If it's 2, it's between 0 and 0. It's 0. And z is going to be everything else, right? So z is going to be a to the r, and then all the b's and all the c's, right? Because we said y was just a's. So the z has all the b's and c's. You guys with me? I'm just thinking about what does x look like, what does y look like, what does z look like? Yeah.
What does z A to R minus A to Q?
Yeah, so what's r? So the question is, how big is r? We already know m, but so r is going to also be between 0 and 2 minus p. Does that make sense? Yeah. Because if x is already taken up one of the a's and y is taking up one of the a's, right? I guess it's 2 minus p minus q, right? You want to get really, you guys, however many x took, however many y took, right? Are you guys with me up to here? Because this is weird. Yes? Okay, so if y is just a's, then here's what x, y, and z are, right? And then we say, all right, well, what is, and we try x, y, y, z. That means x, y, y, z equals, let's see, we've got a to the q, which is x, y is a to the p, and then we have another a to the p, right? And then we have my A to the R, B to the M, C to the M, right? That's what X, Y, Y, Z is, right? Because I just put in two Y's. You guys see that, right? Which is, let's see. Q is between all of this stuff, right? Let's just argue that even though we don't know what X and Y are, I could say that that's actually 2 A's plus P more. You guys with me? Because I have the 2 A's that I had before, and then I have an extra copy of Y. Right? So that's the same as A to the 2 plus P, B to the M, C to the M. Right? Right? Oh! But that's not in my language. Because I know that P is greater than 0. Right? Because Y can't be empty. You guys with me? So far it's not in my language. It's not really a contradiction yet. It just says, oh, you know what? I got the form of A wrong. Are you with me? A doesn't look like, sorry, Y isn't just A's. Y must either be this one or this one. Just like, it's not a pen. It must be one of these other things. You guys with me? But it's still plausible that this could work. Okay. If we look at case 2, Y is some A's and B's, right? Then Y is going to take the form A to the P, B to the, I don't know, Q, right? Where 1 is less than or equal to P is less than or equal to 2. And I guess Q one is less, so there has to be at least one Q. And what's the most number of B's I could have?
M minus P.
Well, not even M minus P. I think it's M minus 2. Because I know I got those 2 A's at the front, and the Y has to happen in the first M characters. Right? So, something like that. At this point, I think I can say, let's see, so X has to be all A's, right? X is going to be A to the 2 minus P, right? Whatever A's are left over. Z is going to be B to the M minus Q, C to the M, right? So X, Y, Y, Z is A to the 2 minus P, A to the P, B to the Q, A to the P, B to the Q, and then B to the M minus Q, C to the M, right? And if we look at this, I've got some A's, some B's, some A's, some B's, and then some C's. That's not my language because I can't mix the order of A's and B's. Right? And we can do the math. A to the 2 minus P followed by A to the P, right? That's just A to the 2. And B to the Q is going to be B to the Q, right? A to the Q, 2B to the Q, A to the P, and then we've got B to the M, C to the M. I think if you add it all up, right? But it doesn't matter. That's not in my language. Right? Because you can't mix the order of the A's and B's. You guys with me? Yeah. And then we need to do the third case, which is what if Y is just B's? Well, if Y is just B's, right? If Y is just B's, then X is going to be all the A's, right? And some B's. Let's see, what's y? We'll do y first. Y is going to be, I don't know, b to the p, where p has to be at least 1 and can't be more than m minus 2. Right, because we got those first 2 characters, and then we got m minus 2 more to make m of them, which is where, because y can only go up to the first m. Yeah? And x is all the a's, followed by some b's, you know, b to the q. I don't know how much q is, but I do know that q is between 0 and m minus 2 minus p. And z is the rest of the b's, right? So b to the m minus p minus q, right? Get rid of all the other ones, and c to the m. So if I look at x, y, y, z, then I get x is a to the 2, b to the q, we got b to the p, and then we got b to the p again, and then we have z, which is b to the m minus p minus q, c to the m, and if I add these up, what have I got? M minus p minus q, I end up with a to this 2. I add these exponents up, right, and I get b to the m plus p, c to the m, and this is how I should have done the math for this. I should have said r is actually equal to, so over here, if I had said, I know for sure that r is actually all of the b's that aren't used yet, so it's going to be m minus p minus q, then this math would have worked out more easily. It's the same thing. Are you guys with me? How many, oh, no, that's totally wrong. How did you guys let me write that? Z is going to be, R is going to be 2 minus P minus Q, right? There's 2 A's, take away the ones I use for P, take away the ones I use for Q. Done, that's how many A's are left, right? And if I do that, then the math works. So we've got, my string is 2 A's, M plus P B's, where P is greater than 0, and then M C's. Well, that's not in my language, right? Now this is where we get the contradiction. Well, Y has to be either just A's, or some A's and B's, or just B's. It can't be any of these, right? But it has to be because of the pumping lemma. But it can't be, but it has to be, but it can't be. So since it can't be any of these possibilities, now I have a contradiction. So I say, you know, thus my assumption must be false, right? Right? What did I assume? I assumed that A to the 2, B to the n, C to the n was regular, which means that A to the n, A to the 2, B to the n, C to the n is not regular. Therefore, A to the n, A to the 2, B to the n, C to the n is not regular. Q again.